Welcome, everybody. Um, this is my opportunity to talk about the black box environment testing, and I'm going to show you the different scenarios where you have to test your product. We're going to start with the environmental stress screening. The purpose is to find defects on the during the design and manufacturing process. The rationale it's to find out if there are any defect problems, especially during the workmanship process. If there is a poor workmanship process. The objective of this is to improve the quality of the product. The method that we're going to use is it's a technique of applying various types of stresses, uh, which can be temperature, vibration, humidity, and electrical stimuli. And we're gonna do this applying as much as we can, as much stress as we can make, so it mimics what the overall life cycle stress is going to happen. Mm. These ESS tests include two variants, one being the HALT, the other being the HAS. So we're going to start with the HALT. HALT is defined as highly accelerated life testing, and is used during the phase of a system applying stresses. Uh, if there are faults, we have to fix those and improve the design. Um, the following procedure has four steps. One, it's applying environmental stress until the system fails. B would be making a temporary change to fix the failure. C would be stepping stress further until the system fails, and repeating the stress fail fix process. And the last one is going to be the finding the fundamental operational and the struct limit until it's not economic. Which this we with this we mean if something happens to our product, like the shower, something really bad happens, and it's not economically to find the what went wrong. Like, for example, if the compressor goes wrong or the tank water goes wrong, something happens, something bad happens, and we have to pay a lot to for those parts, and it's just better just to change the entire system. Um, on the HAS, it's highly accelerated stress screening. It's a non-destructive test, and it normally consists of the following steps. A being the stress predetermined percentage of the product. B, detect manufacturing defects and perform failure analysis. C being the perform corrective actions to that may include fixing failed system. EMI and EMC testing purpose. The EMC, which means electromagnetic compatibility, deals with unintentional generation, propagation, and reception of electromagnetic energy with a specific attention. The second one, the EMI, means electromagnetic interference. Electromagnetic interference covers individual electromagnetic pulses. The rationale for performing these EMI, EMC testing is as follows: is to verify the system under the test operates. The second one being to verify that the system does not emit to the environment electromagnetic radiation, which our product does not have to do with anything like this. So let's move over to the next slide. EMI, EMC testing verifies that the electromagnetic interference characteristics of an electrical and electromagnetic system meets its specifications. The destructive testing. We refer to the destructive testing as a system rather than material or component destruction test. Some of the costs for this testing is going to be very high. So several analysis and mathematical modeling and simulation tools have been developed in order to compute the behavior of materials and structures under dynamic loading conditions. The destructive testing, it's carried out in the automotive industry just to see the crashings, the side crashes, and all of those tests where they test the product. In our product, it's going to be very difficult to do a crash test. Well, not very difficult. It's more like it's not something that we're going to test with the product with. The destructive test is not confined just to automotive industry. It also trains crashes that, like for example, locomotive impacts, and so on and so forth. The destructive testing, it involves not only involves automobiles. It also involves aircrafts, and for the aircrafts, there's not that many crashes that they do because of the economic impact, but the industry seems to be successfully in convincing the public that the air transport is safer than the passenger car. The rationale for the destructive testing would be to reveal hidden system defects. For example, in the automotive industry, they have to do a lot of prototypes, and vehicle manufacturers, they often spend $100 to $150 million to get to what they want. Hopefully, we will not need $100 or $150 million to test our product. Another test that we have is the reactive testing. This test it's a undertaking when a system is either especially complex or exhibits nonlinear or erratic behavior, often necessitating a test strategy. The main characteristic behavior of such system is often not fully predictable. Thus, testing must look for odd behavior in remote niches of the system behavior space. The rationale for the reactive testing would be the automation, the reusability, effectiveness, robustness, and efficiency. These play an important role while testing your product. For example, the reusability means how we're going to reuse our system in different stages. Effectiveness, it would be how to react on significantly more effective at finding defects. The robustness. It's about the faults that happen during the design and they are already been detected. The disadvantages of the reactive testing would be coverage in gaps, repeatability limitation, and test oracle problems. On the coverage gaps, it would mean purely reactive testing approach can lead to coverage gaps in the space, in the testing space. For the repeatability limitation, the nature of reactive tests is twofold. They evolve over time, following one another at a very rapid rate. For the test oracle problem, it would have the predesigned test. There is typically a defined expected result or some other way of determining whether the test is passed. The purpose would be, for many embedded systems, correct system functioning depends on temporal correctness as well as logical correctness. That being said, we need to find in our system the logical correctness, and the dynamic testing is the most important analytical method for verifying the temporal quality of embedded systems. The rationale for the temporal testing, like in the car industry, the airbag must fully inflate with a certain amount of meters from the initial impact, and if the airbag will inflate in say 100 meters, then the system will be ineffective in protecting the passengers. This type of testing, it's quite unreliable due to errors introducing computer and execution times. However, the testing should be mandatory part of the verification validation process of certain embedded systems. The temporal behavior of a real-time system is effective when the system is in a given state. The main task of a test engineer, therefore, is to find whether or not such system states they and or input a combination exist. In other words, the test engineer must generate a set of test cases in order to detect the system timelines defects. So finally, in the case of an event-trigger real-time system, the engineer must consider factors like the non-deterministic execution order typically exhibited by such systems and the temporal impact exerted on the system by its environment.